Okay, let's take a quick look. Looks like maybe there's still some questions, and I get why, on the fifth assignment, solving from the systems section. That's a big section. Solving linear quadratic systems algebraically. So what are we going to do with one like this? I mean, we have the options. We can always use substitution, right? And then sometimes if it makes it easy, sometimes we can use elimination. We just add the equations and get a variable to drop away. Which one are we probably going to use here? Probably substitute for x. Now we definitely we would not want to substitute for y, would we? No. Right? Do everybody see why? Because we don't want to have to square something complicated out, right? Because the y is the part that's being squared, we'd rather make the simple substitution for x instead. So we'll make the substitution here. We'll use this equation to create our substitution equation. It's easy to isolate x there. What's x equal to?
65.
Okay, 12y plus 65. And then we're going to plug that into the top equation, right? And if we do that, we're going to get -4 times the quantity y plus 5 squared equals that. 12y plus 65 minus 5. Okay? So now what? Yeah, we want to simplify. So 65 minus 5 is 60. Okay, now what? That question. Could I distribute the -4 here?
No.
Cannot, because it's being squared. Good. There is something really convenient I can do, though. Divide both sides by, and how about -4? Okay, now that works out really well. If I couldn't do that, it'd make the process of simplifying this a little tougher, because I'd end up having to distribute something after I square this out, right? But I can divide both sides by -4. So that's going to cancel the -4s there. And then I'm left with the quantity y plus 5 squared equals, now I got to divide these one at a time. What's the first term going to be? Good. Second one? Minus 15. Okay, now I'm kind of stuck, right? My goal here is I want to come up with a quadratic equation in the variable y, because then put it in standard form, because then I could solve it. I have a quadratic equation, but it's just not in a good form. So I've got to expand everything out, multiply out this y plus 5 squared, and collect the like terms on one side so I can put it into standard form. So what am I going to get if I expand out y plus 5 squared?
Y squared plus 10y.
Okay, good. Because I just know, a plus b squared is a squared plus 2ab plus b squared, right? So we're going to follow our pattern. Now I just have to put it in standard form. So I'll push everything over to the left. And when I do that, how many y's do I get? No, because I'm going to add 3y to both sides. So 13. And I'm going to add 15, which gives me
40.
Okay, there. Now we've got a quadratic equation in standard form. And so this takes us back to all that Unit 2 stuff that we dealt with, right? We want to solve this the easiest possible way. Well, we can't isolate x. Or isolate y. We have two different types of y's here, so we can't isolate the variable. But what's the next easiest thing to look for? Magic numbers. Do they exist? Yeah, they do. What are they? 8 and 5. So this factors so that's going to give me what two solutions for y? Okay, so we get y equals -8 or y equals -5, but we're looking for solutions to a system, so we need both the values of x and y, right? So now here's where we can go to find the corresponding x values. If y equals -8, I can go up here and find the corresponding x value, right? So if I plug a -8 in, what am I going to get? So what, -96 plus 65 would be what, -31? So there's 1 point, right? We want the other one. If y equals -5, we're going to get what, -60 plus 65 is 5. Okay, does that make sense? Okay, everybody see that? So those would be our two solutions. Now, is it, so this could be a pretty ugly problem if there weren't magic numbers, right? If there weren't magic numbers and I ended up getting some irrational number with like radicals in it and things, you know, I don't think you're going to get any like that. I don't think I did that to you, but if you did, all you'd have to do is just still plug it in up here to find the corresponding value of x, right? It's going to look kind of ugly, but it's just a number, okay? Now, one other thing I'll point out, remember that we only want real solutions, okay? If no real solutions exist, and they're false, right? So if we were going to have to do the let's say magic numbers didn't exist, and we were going to do the quadratic formula, where would we always want to start with the quadratic formula? The discriminant, right? We want to see right away if the discriminant is going to be negative, you're done, because the answer is false. That would give you imaginary solutions, right? Okay, make sense? Okay, all right. How about it?